Okay, let's continue here. So I want to focus on maybe a kind of more, not really theoretical, I guess, but kind of zooming out to like a general level, just thinking about maybe two important aspects of sound production. So here I used, there's another great module called Notes in the fundamental set. So you can write notes to yourself all over your patch if that helps. They're like little comments. So we can think of these two aspects being sequencing or triggering, and then also sound sculpting. And so I already kind of patched this thing together here. So maybe with the first one, we think about, okay, how do we actually trigger the sound? So that's either with using the keyboard as a trigger. Right now I've hooked up a little MIDI keyboard here. And we can see this with the MIDI CV thing. So it's my little micro key 25 keyboard. So that's it's not just triggering, but it's also giving a kind of V-oct information. Before I also did it with this little random thing here. But then for the sculpting side of things, we can kind of isolate, right? Maybe this part here. So the actual raw material of the sound is being generated by this VCO. I've got sine, triangles, sawtooth, square waves. The ADSR envelope really kind of shapes it into different temporal objects almost. Throughout, I've talked a lot about in Touch Designer also thinking of chop channel data like it's clay, and we kind of shape that data into the form that we need it to be in to do what we want it to do. And with modular sound production, I feel like this is really a great metaphor because you can really, your ear can tell the difference between how you shape that sound. So shaping it with this envelope, and then shaping it more with a filter to kind of cut off certain frequencies, boost other frequencies, right? So it's definitely like this big hump of clay, and you're shaping it. So these things of like sequencing / triggering, and then the sound itself having a certain shape, always go hand in hand. And typically that's all being kind of modulated. So one trick here I want to kind of point out, our VCO has these 4 different types of waves that are coming out of it, and I'm putting it into a VCA mix. So all 4 of these waves are coming here, which I can then kind of mix. So you know what I'm going to do? Maybe I'm going to get crazy. I'm going to get a little LFO. Or maybe I'm going to get like 4 LFOs. And let's put it where we can see it. Okay. And what if I don't know, let's just do this. I'm going to kind of like maybe give each of these. There's easier ways to do this with other brands of developers of other modules, but we can do this with our fundamental collection just fine. All right, so these LFOs are all slightly different frequencies. So now this mix, maybe I'll set them at a kind of equal level right there. So I should start to hear kind of like swooping. What if I did another, let's do like a saw wave on the cut. Let's see what happens there. So now the cutoff is going up and down also. Okay. That's something. So we could just play around endlessly, and you should play around with just how does it sound when I kind of move this ADSR faders up and down. We could use some other randomness or LFO coming in here to affect those values also. So always remember, right, as you add the CV to modulate some parameter, you also need to open up the attenuator a little bit. By default, right, that's going to affect it 0%. If I went like this, now like 100% this value is going to determine the cutoff frequency, and then somewhere in between is kind of like, okay, it's kind of sticking wherever you did it manually, but then it's kind of affecting it, a little bit. So play around with that. I want to focus now, maybe shooting back to this kind of sequencing triggering thing, and actually maybe thinking more about what VOCT signals really are. It's kind of easy. I've got this keyboard, right? And then the keyboard note value that I hit is kind of coming in here to my VOCT input, to my VCO. And I hit C, and it sounds like a C. Okay, great. But like, what exactly does VOCT mean? I want to kind of drill down a little bit more. So all of these, like all the information coming through, and we can kind of see when we scroll over, if we do like view show tooltips, that's how we see that. So this is kind of nice, especially when you're learning show tooltips, and you get a little reading of the voltage coming through there. So I see this looks like it's going from like 0 to 10 volts mostly. And then how about this? So this is like, looks like it's moving a lot faster. Right, this gate is like 0 now. Now it's 10. Okay, cool. How about the envelope? If I do that, that's at 0 volts. Goes up to 10 and then down. And I release and it goes down to 0. Okay, great. So it's all voltage. How does VOCT exactly work? Let's look at a table. So here's a little table that it's helpful to keep in mind if if you care about keeping in tune or scales and things like that. The quantizer is kind of automatically shoving for instance our random notes here. It's like shoving that into certain voltage values that correspond to the 12 chromatic scale notes. But here we can see, let's say from like middle C up to the C above that, we've got these 12 notes of the chromatic scale. Here would be the voltage values for each of those. So when we say like, this type of signal is 1 V per octave, so we can see this right here. So 0 volts, of course, if we plug that into some module that has a VOCT input, 0 volts would correspond to a C4. 1 volt would correspond to a C5. And then you do the math. Basically, it's like 1 divided by 12, which equals 0.083. So for each of these steps, we're increasing by 0.083, right? So if you wanted to get a G note, like here you go. That's what it would be right there. Over here, also this table. So I've got the frequency in hertz also, if you're into that sort of a thing. For most things, most modules, we don't need to know the exact frequency in hertz, but it's good to know, like at least for the VCO here, it does say, right, that says 261.63 hertz. So we can see that's C4. So if you didn't want to mess around with this VOCT stuff, if you knew like certain notes, you could say like, okay, I want to actually do like an F sharp. What is that? 369.99. I could right click. Boom. So that's an F sharp now. And let me see. There. So I'm still like pressing. So now like the key I'm pressing on my keyboard is essentially only acting as a gate for my envelope here. The VOCT is not receiving anything from the keyboard. It's just using the frequency data that I put here. And just to kind of show that again, what if I did like 440 is typically the kind of middle A value. So right click 440. So that's a middle A. Okay, cool. So I guess that matters to know frequency if you wanted to do something like that. Like maybe you just want like a drone that is just like at middle A or whatever, then you can just type that in directly if you're into that. And then, right, so the octave below that, So this gets a little bit weird because, okay, then we're kind of dealing in negatives. So whereas like B4 would be 0.917, B3 would be negative 0.083, right? So on down to -1. And then, right, C2, -2 volts, -3 volts, and so on as we go up. So this going up is a little bit easier because basically we just add 1 volt because this is all positive numbers. So if I wanted, let's say, like a G5 note, that would just be 1.583 volts. Why would we need to know the actual voltage? Like, well, you know, we can get away with it. Like, so, you know, before I was kind of playing with this little random thing, right? So we've got random notes coming in here. I mean, I could just see at a glance from the scope here, it's roughly from +5 to -5-ish. So I know that, you know, thinking about that, like that's actually a huge range. So +5 was like a C9 octave, a C9 note. -5 would be like C0, C -1. It's like a range of 10 octaves, which is bigger. Like a normal piano is like, what, 8 octaves? Something like that, 7 octaves. It's got usually like 88 keys, right? So that's between 7 and 8 octaves, I think. So a range of pitches that's 10 volts wide, like that's a huge range, right? So probably I would do something like, let's like scoot these overs. So I'll do like a VCA. Maybe I want to attenuate this. So I use this word attenuate a lot. Just means kind of like scaling down. So instead of 100%, let's do like 10%. Or let's do like maybe 20%. Let's do this. So now, okay, what's 20% of 10 volts? So now the range is 2 volts. So it should be going from +1 to -1. And we can kind of see that in the scope right here. Right, so now it's going from C3 would be the lowest note, C5 would be the highest note. Okay, but the random thing here, right? It's continuous. So if we go back, if I show this again, all right. So again, my envelope is set to gate from my keyboard here. V octave be coming from the random though. So I'm just holding down a key. Cool. So that's very continuous, right? And then using a quantizer, just to kind of drill this point home again. So all these like random continuous values from -1, actually from this is going -5 to +5. So we can do, ooh, you know what? Yeah, I want to do the VCA first. So what if I quantize this first and then go through this VCA? Boom, boom, boom. And let's say let's be a little vanilla here. Let's do like a C major, like get rid of all those minor notes. And even maybe let's get rid of a B and the F, and just whatever. So that's being quantized first, but then whatever, this comes out with a certain voltage numbers, right? And then those voltage numbers are being essentially multiplied by 0.2, so it becomes 20%. So actually by quantizing it first and then multiplying it or dividing it, however you want to consider that, we lost our quantized notes. So like whatever's coming out of this VCA now is no longer going to be like a C and a D and an E and a G and an A, because we just like did this math on it. So if we wanted to do something like that, we should kind of attenuate it first. I'm going to like shift and click to just delete these cables. Okay, boom, boom, boom. All right. So now we're going from, instead of -5 to +5, we're going -1 to +1, continuous smooth voltages, which are then quantized. And let's just go ahead and see that they're also, okay, we see little steps now in there. Um, okay, so that's at least understanding how voltage becomes a Voct signal, right? So we're starting to see like understanding that gives you more power. Also, we have certain modules like this 8-vert, which really it's meant to do a kind of let's just kind of look at this here. So grab this here. So by default, this LFO, we can see it's set to offset. So it's in unipolar mode right now. So it's going from 0 to 10 volts. And what an 8-vert does, it can, oh wait. Let me see the output here. Boom, boom, boom. There we go. Okay, super. Okay, great. So my LFO coming in from 0 to 10 volts. So this is actually multiplying it by 0. So our purple line here we can see is just 0. If I multiply it by 100%, it's equal. So this is we can scale signals like this. Doing maybe make it negative. Okay, that's cool. All right. Another way we could use this, if there's no input whatsoever, check this out. I just get like a constant voltage, right? So I'm always kind of like referencing maybe some chop operators from Touch Designer, since we're more familiar with that right now. So using an 8-vert module is a good way if you just need like a constant value. So let's say, okay, I'm going to snap that back to the original thing. I'm going to maybe generate some Voct signals with this. I like that little low crunchy thing. So what if I did, okay, I want a C sharp 3, let's do like a negative 1.917. Okay, so negative 1.917. Okay, that's juicy. So I know from here. So once we're in the negative here also, then I know I can just subtract another 1 from that to create a C sharp 2, right? Or do I want to be crazy here? Negative 2.917. Ooh. Okay, that is thick. So by knowing how voltage corresponds to Voct, I'm able to, let's say maybe if I had like lots of things happening and I just want, I've got this 8-vert, I'm doing some constant voltages here and there, and I'm like, oh, I want like a C sharp to tune with something else, then right click, and I know this magic number of negative 2.917, which will correspond to a C sharp. Okay, cool. That's good for this video. We'll do sequencing next.